Welcome back to Think Thrice Problem Solving. Today we're going to be solving a fun little number theory problem. If you'd like to give it a shot, go ahead and pause the video. Otherwise, we're going to go ahead and jump right in. So we have 24 times a factorial is equal to b factorial. So just a reminder, so if I have factorial, what that means is that I take that number times every sequential integer down to 1. So we do 5 factorial will be 5 times 4 times 3 times 2 times 1. Okay, so if I look at this, I can rearrange. So if I say 24 is equal to b factorial divided by a factorial. So what would that be? So that means that 24 is equal to, let's take this b factorial and write it out as b times b minus 1, and so on until we get to a plus 1. And then that's going to be multiplied by a times a minus 1, which is just going to be a factorial. And I'm going to be dividing that by a factorial. Okay, so we're assuming obviously that b factorial is larger than a factorial, because if it's not, then we're not going to be able to get a solution here. So this a factorials are going to cancel. So what does that mean? That means that here I have sequential products. Okay, so what does that mean? That means I have b times b minus 1. So they're sequential integers that are all going to be multiplied to give me 24. So what I'm looking for are sequential integers that multiply to be 24. So let's look at the number 24. So 24 is equal to 2 times 2 times 2 times 3. Okay, so if I wanted to come up with sequential integers that multiply, let's look at all of the possible divisors of 24. So obviously I can have 1, I can have 2, 3, 4, 6, 8, 12, and 24. So where do I see sequential integers? So sequential integers here, I could just call this guy at the top, he's an integer by himself. And then it looks like I have 4, 3, 2, 1. Okay, so those are also a set of sequential integers. So I have two possibilities here. So when I'm looking at this, I could have b is equal to just the number 24. So what does that mean? That means that I would have 24 factorial. So if we rewrite our equation, I would have 24 times a factorial is equal to 24 factorial. So a would just be 23. So if I do that, I'll see that I'm going to have 24 times 23 times 22 times 21 is equal to 24 times 23 times 22 times 21. So we're going to have b is equal to 24, a is equal to 23. So this is a solution to my problem. Okay, so that was probably the most obvious solution that jumped out to us. But we also have the sequential values down here that multiply. And if we think about it, if I multiply 4 times 3 times 2, that's going to be 12 times 2, which is 24. But I also have 4 times 3 times 2 times 1, which is 24. So if I was to make b equal to 4 factorial, then let's look at what that does. So that means that I have, or b would I just be 4, sorry. So I'm going to have 24 is equal to, or 24 times a factorial is equal to 4 factorial. But 4 factorial is just equal to 24. So I would need to have a factorial is equal to 1. So when is that going to be true? So a factorial is equal to 1 when obviously a is equal to 1. So one solution here would be that a is equal to 1 and b is equal to 4. And there's also one kind of sneaky solution in here. It also happens to be true that 0 factorial is equal to 1. And I know that doesn't really make sense with how we defined our factorial above, and you may see a future video where I go into some details about why that's true. but with a slightly different definition of factorial, we show that 0 factorial is equal to 1. So our two different solutions that come out of that scenario are a equals 1, b equals 4, and a equals 0, b equals 4. So these are going to be the three solutions to our equation. I hope you enjoyed working through this. If you did, please hit that like button and subscribe. And as you're working through problems on your own, think once, think twice, and if you really get stuck, think thrice.